Hi, my name is Mike Raper. I'm Brand Director for North. We're always chasing higher performance, chasing an even stiffer, lighter rig that holds its shape when under load and is ultimately more efficient with zero deformation. During our design process, we realized to create stiffer rigs without geometric compromise, we needed to concentrate on developing new, low elongation materials. Materials without a high performance price tag. At North, we're very lucky to have exclusive access to the world's leading performance material designers in-house. We've been working for the last few years tweaking and tuning materials to fit our wings and kites. We've blown up a lot of inflatable samples, testing on and off the water, often with a big bang. N-Weave is the first material innovation to be applied to a North wing. N-Weave is a high tensile strength woven fiber that we use in our struts and our leading edges. Due to its stiffness, N-Weave reduces structural deflection and it has a very highly efficient power delivery. I'm so proud of how far we've come in this pursuit, but even more excited about the opportunities that lie ahead. The future of North material development has so many possibilities. It feels like we're just getting started. Based in the US, materials technology expert David Little is part of the North development team for North Sales, the market leader for lightweight, performance, and durable material development. With multiple America's Cup campaigns and years of material innovation, Dave's role has been to research and develop our own materials in-house, leveraging resources available throughout the wider technology group. Dave Little joins us today to help explain the technical detail and how the new material is going to transform your ride.
N-Weave is a high tensile strength woven fiber material. It's engineered from 67% UPE and 33% polyester that's been ultra processed for maximum strength and minimum weight. We have a dedicated loom at North Cloth in Sri Lanka to make our N-Weave material. First, we spin the raw fiber onto spools. The warp and the weft fibers are then loaded into a heavy-duty loom, keeping the warp fibers as straight as possible. We're trying to have the least elongation in the warp direction or the long direction of the wing, that when the inflated structure flexes, it doesn't have to take up any crimp first. Once the weave is done, it goes through the laminator where it is married to a recycled PET film and the color is added. This film will be on the inside of the inflated structure, providing some biostability and also a watertight barrier. UPE is an ultra-high modulus fiber, and modulus measures the resistance of material to stretching. High modulus materials stretch very little when they are pulled and have incredible resistance to deformation. This is important because if the inflated structure deforms under load, it won't perform like it is designed to. Using stretch resistance UPE allows the wind energy to transfer more directly into the rig. This is a super efficient material. UPE fibers also have very high cut and abrasion resistance. They are well known for their lightweight, their durability, and their toughness, and are used in some of the most extreme conditions in things like military body armor, industrial-sized fishing equipment, and around the world racing boats for sails and for ropes. The UP fibers are resistant to water, to moisture, to most chemicals, to UV and microorganisms. This is going to be a really long-lasting material. So the N-Weave fabric is 40% lighter than a traditional Dacron. The UPE fiber we use to make the N-Weave is 11 times lighter than a polyester fiber of the same braking strength. The weight savings translates into greater performance. The wing gives you more efficient power delivery in light air and makes the wing much lighter to handle in transitions and maneuvers. Even walking down to the water is easier. For every 2 strands of UPE, we add 1 strand of polyester to the weave. This 2-to-1 ratio is a North Cloth proven recipe to guarantee maximum bond strength during the lamination process. UPE fiber is plenty strong enough on its own, and we treat it with an extra step in the process to give it excellent adhesion. By adding 33% polyester, we strengthen the bond to the recycled film even more. In a tensile strength test, the force needed to stretch the end weave material is actually 3.5 times more than the Dacron. But a wing or a kite is going to be used when it's inflated, not when it's flat. So we created an inflation test by replicating a tube section with the same seam design as the leading edge. This meant that we could test the end weave at a given diameter and inflation pressure, and also test the seaming techniques. All the tests were taken 2 times over what we would recommend for a given diameter without fail. But don't try this at home. In abrasion and UV experiments with the North Lab in Nevada, the end weave was almost indestructible. We also carried out segment seam and closing seam pull tests to find the right combination of reinforcement material, and it turned out that the right reinforcement for end weave is end weave, and we use a double ply of the material on all the seams. I think that we're always chasing greater performance from our materials. To bring the very best products to our customers, we needed to establish greater quality control throughout the entire manufacturing process. By developing our own technology, we can engineer exclusive materials in-house and have complete control over the quality and the finish. We can ensure social responsibility through our factory working conditions and sustainability by choosing recycled components. With our experienced design staff based in Sri Lanka and our facility in Minden, Nevada, we've been able to develop the process and the chemistry behind these unique recipes. It's been a long journey, and we're extremely excited to finally introduce these new materials into the North products.